a heating element using nichrome connected to a 230 volt supply draws an initial current of 3.2 amps which settles after a few seconds to steady value of 2.8 amps. What is the steady temperature of the heating element if the room temperature is 27 degree Celsius? And they have given the alpha value, that is 1.7 into 10 raised to minus 4 per degree Celsius. See, wherever there is a temperature is mentioned, then you have to use the formula of delta R is equal to R1 alpha delta T. Okay. So here they have given is voltage, that is power supply, given is voltage, that is 230 volt, and they have given initial current, that is I1 equal to 3.2 amps which settles after few seconds to a steady value. Steady value they have given, that means I2 is 2.8 amps. What is the steady temperature? See, steady value is I2. That means we have to find out T2 here. Okay, this is the steady value of temperature of the heating element. Okay, and they have given room temperature value, that is T1 equal to 27 degree Celsius, and alpha value is 1.7 into 10 raised to minus 4 per degree Celsius. See, for this formula we have to know R1, but here there is no R1 is mentioned, so we have to calculate first R1 is. So I will write this equation here, R2 minus R1 equal to R1 alpha T2 minus T1. Okay, so R1, how you will find R1? We know the R value, R equal to V by I. So here we have to find out R1, and we have the value of I1 here, and voltage will be same for both the current. Okay, so V value is 230 divided by 3.2. So no need to solve this values. I will write it directly, 230 by 3.2 ohm, and R2 value is V by I2, that is 230 by 2.8 ohm. Okay, so apply this in this equation. See, we can directly cancel out 230 and 230 from this values. Okay, for that sake I will solve this equation again. So R2 equal to R1. Remember, previously I solved this equation, that is R1 plus R1 alpha T2 minus T1. Okay, here we can take R1 common into 1 plus alpha T2 minus T1. Okay, so here we know the value of R2, that is 230 by 2.8, and R1 value is, so 230 divided by 3.2 into 1 plus alpha T2 minus T1. Okay, so this will get cancelled, and this will be 4 sevens are 4 eights are, that is 8 by 7 equal to 1 plus alpha T2 minus T1. Okay, so we can take this one this side, 8 by 7 minus 1 equal to alpha T2. Apply the value of T1 here, that is 27 degrees Celsius. So this will be 1 by 7, which is equal to 1.7 into 10 raised to minus 4 into T2 minus 27. Okay, so solve further. 7 into 1.7 into 10 raised to minus 4, which is equal to T2 minus 27. So from this equation we can solve this by taking this 10 raised to minus 4 upper side, that is divided by 7 into, we can write this 1.7 as 17 by 10 equal to T2 minus 27. See, there is one more 10 here. Multiply this numerator. So 7 into 17 equal to T2 minus 27. So if you solve this, your value will be T2 equal to 867.3 degree Celsius. Okay, solve this. So we have discussed 3 problems on this